Hello, Ken Weller, New Tech Inventors. I'm down here at the print farm, and what I'm going to do today is I've been down here cleaning up and doing my regular maintenance. It's a Saturday afternoon. It's getting a little late, but I'm going to try to take the video that I shoot here this evening and do minimal editing on it just to get something out there to you guys, since it's been a while since I posted a video. So you'll have to excuse me if the video is going to be a little rough around the edges. I've just finished about 4 hours of cleaning up, reorganizing a few things. My ANET AT4X printers here with the textured PEI sheets. They all have 0.6 nozzle, and we have some more PEI sheets down here that we need to get installed, some smooth, some textured, on some more of these ANETs. I need to keep some of the ANETs with the glass bed because I have some parts that print real well on the glass bed, and I like that smooth surface. But then other parts, especially larger parts that have exposed surfaces, I find that the textured surface works a lot better with the PEI sheets because well, I'll show you. On the lap diners, for example, we're printing those on these Tronixy XY2 Pros, and they have the textured sheet. And you can see they fit well within the boundaries. I can't really print these on the ANETs because, as you can see, they'll fit on the 220 by 220, but the perimeter gets too close to the edge and it doesn't get good heat distribution, and it's more prone to warp and cause one of these corners to roll up. But I like getting these textured finishes on these parts. Most of them come out pretty good. The texture does a pretty good job. Over here on these, does pretty good. The brown, we're doing pretty good with the brown ones. So we've been printing quite a few lap diners on these Tronixys, and you can see my mess here. This is what happens after a week of printing. There's just a mess. This is where I had to replace several of the rollers. That's another thing too on these Tronixy XY2 Pros. If you have one of these, you want to make sure that this bed doesn't have any movement. And after a lot of printing on these, I had these two printers right here, the back corner, there was some movement. And I tried to check and figure out what was causing it. And finally I resorted to changing out the rollers. So I changed the rollers on these two. And I also installed some heavier springs, but that took care of it. And now they're printing good. They'd gotten to where they weren't printing very well because they would start out and print as if it was level, but then the back would drop a little bit, just a fraction. It just kept messing up my prints, so that was the problem, and I went ahead and changed those out, and everything works fine now. So I'm going to look at these a little closer and see if it's the bearing inside of these that got some slop, or if it was just normal wear on the rubber itself that allowed it to have a little more gap in there, but I couldn't adjust it out or anything else. But that did take care of the problem, actually changing the rollers. That's a little bit about the XY2 Pros. I'm trying to get things cleaned up. I've got a problem with this printer down here I need to fix. I've been printing some of these parts on the ANET A8 Plus printers. This kind of a work area here. These are a lot of the 0.6 and 0.8 millimeter nozzles that I use. And printing with 0.6 and 0.8 millimeter nozzles, I'm doing a lot of that on a lot of these printers. Even on my king runes over here. And if you notice from a previous video, I've changed this shelving a little bit. I've moved this shelf up and no longer using it for printers. And I have the printers down here, and I can use my filament holder there, and I can use the filament holder up here now with these, which allows me to feed filament directly into the extruder without taking up space and having to use these rollers that come with it, because when it gets near the end of the spool especially, that filament can come off of those rollers. I prefer not to use those. Plus it takes up space back here. Putting the filament up here solves that problem, so I'm going to bring over some of the vertical and some of the horizontal filament holders that I've made and put them on these. I think I did a video recently where I've already replaced all of the filament holders up in the bonus room. I have about 7 or 8 King Rune KP3s up there, and I've put those new spool holders on there, and they work great. Anyway, that's a little bit about some of the things I've been doing. When it's a one-man operation, it takes a lot of time just to clean up your mess after a week, sweep up the floor, get all your parts that you've made and get them in these different bins and get everything sorted out so that these are the foot switch parts. These are the rollers for the filament holder, and these are some of the parts for the lap diners. But that's a little bit about what I've been doing today, is just getting the clutter all cleaned up. I'll come back, I'll probably do a little bit more tomorrow and maybe install a couple more of these PEI sheets, spring steel sheets on the beds of a couple more of these A-nets. This whole top row of ET4s, A-nets, are all glass bed, and they'll stay glass bed because I have certain jobs and parts that just run on those. So when my inventory gets low, let's say on the spacer for the helping hand, that little spacer adapter, this printer on the end, it does nothing but print those. And it prints, I believe, about 12 or 15 at a time. So I can run that thing for a couple days and get a whole bin full of those parts. This one prints the 3-port adapter for the helping hand, and it prints about 10 of those at a time, and so forth, different parts. So that's the way these printers are set up, and since that works good on glass beds, if it ain't broke, don't fix it. But I'm printing a lot of parts that go with the lap diner and some larger parts now on these printers. And this particular one was printed on a glass bed, one of these ET4s. This one was printed on one of the textured beds. And the same thing over here. This was printed on a texture bed, one of these printers. I kind of like the surfaces from the textured PEI sheet, and it's very easy to remove the parts quickly right after you finish printing. And some of these printers run for 24 hours. So when I come in the next day, sometime within that hour or so that I'm down here, I expect all of my printers to either be finished or finished during that time, so I can remove the parts and restart them. And if they finish while I'm down here, the glass bed printers have to be cooled off. Sometimes I have to actually take the glass off, take it in, set it up in front of the air conditioner, and quickly cool it down so I can remove the parts. But with the PEI sheet and spring steel, you can just flex this spring steel, and even if the parts are still hot and the bed's still hot, those parts will pop off. So that's one thing I like about that. Well, it's a new year. I hope everyone had a good New Year's. Now we're in 2023. We're actually in the process of getting a lot of new parts on the website, and I have to meet with my marketing person and make sure that they have everything they need to get pictures made of those parts. I've given them all of the parts. I'm about to give them 3 or 4 of the lap diners that we have that are getting ready to go on. We have them in red copper, red, blue, brown, orange. I think those are the 4 main colors that we're going to try to start out with, and see which color does best. We'll probably narrow it down at some point to where we don't have so many different colors of lap diners. It'll simplify the process. We've done the brown because we expect a lot of the lap diners to be used by outdoors people, campers, hikers, hunters, fishermen. I thought that the brown would go good with that. We'll see about that. I've also thought about getting some dark green or even army green filament and trying that out to see how that does, if that goes well with outdoors. Now the colored ones, a lot of the colors, like the orange ones, especially here in Tennessee, would go real good with UT football, since they're the big orange and the Tennessee Vols. We can do colors for different schools. Could do a red for Georgia, burgundy red for Alabama. We could do mixed colors. There are a lot of different colors we could do, but it depends on who's buying them, and we'll wait and see how that all works out. Well, I was down here working. I had the camera down here. I had actually planned on printing some stuff this weekend, and I may print tomorrow on several of these printers because I've missed a few days because of the holidays, and also we had some pretty severe thunderstorms a few days ago. So whenever we have weather like that, I pretty much shut everything down. I may run a few printers, printing small parts or experimenting with things, but I don't like to have a lot of printers running, especially if they're running long jobs that consume a lot of filament and then have a power failure and not be able to get going again. I know I did videos on backups and stuff, and I've got the automotive batteries and some things. I think I'm going to go ahead and make a circuit that will switch out the 24 volts. On most of these printers that I have are 24 volt DC power supplies. So that would mean that I'd have to have 2 automotive or marine batteries in series to get that 24 volts, and have some kind of a trickle charge on those batteries to keep them charged. And then when the power fails, be able to switch the power on the printer itself. So I've come up with a design where I have a little module, and I have a high amperage relay that will take that 24 volts and switch it over to the printer. And on that side of the relay, I'll have some pretty high capacitors to help hold that voltage just long enough for those contacts to switch over so that the printer won't lose power. Then when the power's restored, after a short delay to make sure that the power's going to stay on, then the relay will switch back to the power supply for the 24 volts. And then the batteries can go back on their trickle charge. But it's a pretty simple thing to do, and I think it'll be pretty easy to hook it up to the printers, because you'll just have to take a couple of wires loose from the power supply connection and reconnect them to a little box, and then that box will be wired to the battery bank. And I think if the batteries are pretty high capacity, I could probably have several printers with that device on it going to one 24-volt battery bank, especially if they're larger marine batteries or something that can last for a while and supply a fair amount of power. Because these printers, once they're up and running and preheated, they don't require a lot of power to keep going. I'm going to try that on a few so that when we do have this bad weather, especially on the ANET A8 Plus printers, my larger printers, they usually print jobs that run sometimes 48 hours. I don't want to take a chance on having those printers fail because they're using 0.8 millimeter nozzles. On some jobs, I can use a whole roll over 300 meters of filament in a 24-hour period. So you definitely don't want to get into a job like that and have a power glitch for any reason to stop those printers. And I've had that happen before. And you lose a lot of filament and a lot of print time. So those will be the main printers that I'll be looking at putting on that battery backup. I used to have a helper, but I don't anymore. So I'm having to do all the cleanup by myself. And it takes about a whole weekend to do some of the maintenance on these printers, to just clean up the mess and do the normal maintenance that's needed to keep this place running. I was on eBay and I saw various printers for sale. I've never had a Prusa, but there were some of those on sale, and they look a little bit like these. They have dual Z-axis motors, and of course the control, instead of being up here, is down in front, but they have rails. They're real good printers. I'm sure they use very high quality parts, but these were used printers that people were selling for $700 and $800, and I kept wondering, well, gosh, if I had $700 or $800 to blow, I would buy one of those and just run it to see if it really does more than what I can do with some of these printers around here. I've been very pleased with the Tronic ZXY2 Pro. I've had some real headaches with them. They've been stubborn at times, and I've had different problems, but once you figure them out and set them up enough times for different print jobs, and this is one of the harder jobs to print. Leveling has to be right on. You need to get good consistent parts. The ANETs, I think I know these. I can pretty much work on them with my eyes shut. Matter of fact, with my eyesight the way it is, that's the way I do most of the stuff when I have to change these heads. And I have a lot of problems with them. I can see that this is a replacement assembly right here. Just recently replaced that. I don't remember exactly why, but I need to get it put back together and get it going again. I think, no heat at hot end. I think this may have been the one that had that problem with. But I've had problems with several of these. It's just part of the process. If you can tell me that there's a printer out there that I can run, about 24 hours a day continuous for 5 or 6 days at a time, and not have to change hot ends or have heating elements go out or roller bearings or belts going bad, let me know about it. I might want to buy one of those, but I seriously doubt if there's one out there that can just run continuously and not have to have some parts replaced from time to time and some maintenance. Now, as far as the non-moving parts on these, now I do have some fans, and a lot of that's my fault. I have a fan over on one of the Tronixies where there was a little bit of filament down on the print head that the head was dragging around, and I wanted to get it out of there, so I took a little Allen wrench, tried to flip it out, and the Allen wrench actually went into the fan and broke a blade off, and now that fan over there is making a racket when it runs because it's out of balance, so I have to change that fan. But, some things are my fault. And whenever you have a part that loses adhesion because maybe you didn't get the Z offset right, or maybe you didn't clean the bed surface frequently enough, I have a tendency to get my hands on these sheets a lot. And the oil on your hands is not very good for that, because enough of it on there will reduce adhesion enough to where it can cause those parts to come off. So I have to take alcohol and clean these surfaces every once in a while. Frequently, it just takes a second to wipe them off a little bit to get any oils that have built up or come off of your hands on there. Then you'll have pretty good adhesion. But then your Z offset has to be right too, because you've got to have enough force and be able to push that filament onto that bed with enough force that it will have good adhesion. And then your temperatures of the bed are going to affect that too, and the temperature of the nozzle. As I've said before, I try to print at higher temperatures, especially with the 0.6 millimeter nozzles. I have to print higher. If I have a PLA that it may say on the spool 190 to 220 degrees, well, I'm going to be printing at about 230, because with that 0.6 millimeter nozzle, I'm pushing a lot more filament through that nozzle, and it's not having as much time to heat up. Plus, when you have a higher temperature, I find that I get real strong parts. As long as you don't distort your part or lose the quality of it, the part can be stronger if it can be printed at a higher temperature. At least that's what I've found. So I try to print on the high end, and I have some PLA Plus that I have to print, sometimes around 235 to get it to do what I want to with these larger nozzles. When it gets to the PET-G, that's a problem for me, because to print the PET-G with the larger nozzles, I've got to get the temperature up in that 250 range or better. And when you get up that high, it's just a very hot temperature. If your print pauses and that nozzle stays at that temperature for a period of time, just a minute or two, at that high temperature, that filament in there around the walls of that nozzle and heat block, it will start to harden and adhere to the surface. And then the next thing you know, you're not able to extrude at the rate that you want, because your nozzle is actually gone from maybe a 0.8 to maybe a 0.5. And because of that buildup, you're not going to get what you expected out of your print if you're printing that small a stream. And sooner or later, it's going to clog the nozzle altogether. I think I showed you a few minutes ago the nozzles I have down there. I probably have 500 nozzles or more, and they're all 0.4, 0.5, 0.6, and 0.8. And then I have a few smaller ones, 0.2s, and maybe a 1.0, a few of those, but I've never used them. The highest I go is 0.8, and that's on the large ANET A8s. I've got a 0.8 on a couple of other printers that I test some stuff on, but most of the ANETs and Tronics, they're either running a 0.4 or 0.6. One of the things I really like about printing with 0.6 millimeter nozzle is that it cuts your print time down an awful lot. So I can put more parts on the bed, print more parts at a time in a 12-hour period. The faster you can print something on a printer, the better off you're going to be, because the longer that job is printing on that printer, the more problems you can have. The biggest one, of course, being a power glitch or a power failure. Other things that can happen, changes in temperature or accidentally bumping the printer or something when you're working next to it. I just like to get the print job over with as quickly as possible without sacrificing the quality and the strength of the part. So until the next time, happy printing from New Tech Inventors.